Hello, good afternoon, and welcome to this webinar. So we will start in 2 minutes. Yeah, because I can see the number of people growing. So yeah, we will start in 2 minutes. Hello, good afternoon, welcome. Yeah, we will start in 2 minutes. Yeah, we are ready, and we will start in 1 minute now. Hello, welcome. We will start in some seconds. Okay, so I think that we can start. So, hello and good afternoon again. So I hope you are fine and ready for this webinar. So I'm Didier Sampere, working in the global marketing organization to push and promote all the ranges for chromatography. Today we will present a webinar called "How to Reduce Your Sample Loss to Significantly Improve Your Results." And I'm sure you will agree with me that sample preparation is a key part of the chromatography workflow. And today, Dr. Detlef Lennartz from Thermo Scientific will examine how small changes to your vials and closures can lead to big impact to your recovery rates and reproducibility in your workflow. During this webinar, Detlef will give you more details in the latest developments and tips to eliminate or at least reduce adsorption in an autosampler vial, reduce the risk of moving your analyte out of the target pKa values for reliable liquid chromatography analysis, eliminate sample loss due to evaporation by poor seals. And with that, before the presentation, feel free to ask some questions using the box questions. Yeah, we will answer later. This webinar will be recorded, and yeah, you will receive the recording after. And now I think that we are ready. So I would like to wish you a great webinar. And now, Detlef, up to you.
Yeah, thank you, Didier, for this introduction. Hello, everybody. Good morning or good afternoon, depending on where you are. I'm happy and proud to be here and to talk to you and maybe show you some examples where your analytical workflow could be improved, or your results or your reproducibility could benefit from. My name is Detlef Lennartz. I'm product manager, vials closures or sample handling products at Thermo Fisher Scientific. We do not have a camera here at the moment, so here is a picture of me that you can see who is talking to you today. Let's directly jump into the themes agenda. We want to talk today and discuss a little bit the theme glass adsorption. So what is it, what can happen, and where is the risk for your analytes and your reproducibility? We will talk a little bit about compounds which could leach and introduce non-wanted compounds to your analytes, pH change in a vial, then a little bit about glass qualities and plastic, Microsampling is a different kind and a different type of problem solution, because sometimes you may deal with very small volumes, and this is another challenge. Certification, a few words about certification of autosampler vials, enclosures, and well plates. Then I want to bring a little bit light in the different types of septa which are available, and where can this septum help, and where is it a risk, and why is the septum not always the same, even if it looks identical. Some words about well plates as an alternative to vials enclosures, and the impact of vial types and glass types on your analysis. So a lot for today, different themes, and I tried to collect everything which could be an issue for your workflow and could be dangerous for your substance and analytes. So this is very interesting, and I created that slide a little bit provocative, but I think this is what we want. We want to put 100% of everything what we have, our analyte, our substances, our target molecules, into the vial, and normally expect to get 100% out without any sign of degradation or modification or contamination, right? This is what we want, especially because there may be a very expensive sample preparation upfront, and your end equipment is maybe very expensive, and you expect high sensitivity detection and very good results. But I can tell you, this is a wish, and this is not the reality. You will never put 100% into a sample handling container and get 100% out again. Yeah, well, but the question may be, well, I'm using glass because it secures my sample and it's always inert. And this is the reason glass vials are used in chromatography for samples for more than 40 years now. But 40 years ago, the world was different. And today, the detection limits are about 10⁻⁶ times higher as in the beginning of the real chromatography world. But the vial and the closure did not really change. So what we need and want and expect is a vial where the modification or this 100% input is accompanied by nearly, or best possibly close to 100% output. And what we can offer here in this case is a vial where the glass quality is excellent and has the lowest grade of adsorption tendency here. And we have one of these vials, and not only now, it's in our portfolio for a long time, and we call these vials gold grade, because the surface of this glass vial has the lowest adsorption tendency of all glass vials on the market. And the bonus is this vial, this glass quality, has the lowest pH change. We will come to that a little bit later. So here you see some molecules, and if you find something, functional groups, or even these molecules, and you say, well, this looks familiar, or I'm dealing with pretty similar ones, you are here exactly on the right slide, because when you have 3 substituted nitrogen atoms, tertiary amines, very high polar carbocyclic acid compounds, or amino acids combined, then you are dealing with critical compounds, because these compounds tend to adsorb on glass surfaces. And this effect is time depending. So the longer the sample is in the vial, the more adsorption effects you may see. And the negative effect is, you see it here, maybe there is a loss of around 80% of your target compound, and nobody wants that. And here we are not talking about one vial and one sample. We talk about you stuffing your autosampler with a full set of 100, 200, or how many vials ever, and you expect that vial number 1 shows exactly the same result as vial number 100. But if you have a time effect of adsorption, this may not happen in a way you expect and want it. So you cannot ignore this fact that some molecules tend to adsorb onto glass walls pretty heavily. Here we have an example. It's not that you all have to deal with this type of medicals or drugs or stuff like that, but this shows impressively that the glass quality decides if your reproducibility over time is constant or not. Here on the left side, you have 5 vials over a time of 24 hours. The red line here is your target of 150 microliters. And you see 5 vials over 24 hours. You're nearly with every vial over every time close to where it should be. When you switch to other glass types or other vials, there may be outliers. And sometimes your reproducibility is totally corrupted, depending on the glass and vial quality. So a vial is not a vial. And when you say, well, I'm using, well, I know my molecules, right? And when I have sensitive molecules, I always use siliconized vials, and this problem is gone. Well, maybe no, because you see here results of siliconized vials, and it's not given that you always have excellent results, because sometimes your result may be corrupted even when you use a siliconized vial. And a siliconized vial has another disadvantage, because this is something nearly nobody tells you, because siliconized vials are very expensive, and everybody expects that a very expensive vial is superior in performance. But the siliconization is a chemical process, and you know, chemical processes are reversible. So a siliconized vial always has as extractables or leachables or side compounds, parts of that siliconization, which you may see in your analysis. So a siliconized vial helps sometimes, but not all the time. And when it comes to reproducibility, well, a gold grade vial is superior. And when we compare that not only via glass quality, but what we did is we took a lot of vials out of the market and said, well, let's check. And here you see the fault or this variance bar, which shows, okay, you are very close here or out of scope and totally out of scope here. So it is not given that every company in the world has pretty excellent glass qualities, because glass is not glass and a vial is not a vial. So you see variances and sometimes totally non-expected reduction of recovery, and this is equal to adsorption. I said, well, there are vials out there where the pH of your water sample or your sample in a water environment is changing. Delta pH. Again, the same picture, we saw it before. You put in your sample, and let's say it's water pH 7, and you expect really that after a few minutes or after an hour, the pH is still 7. If you think about that and you are sure that this is the case, then you're absolutely wrong, because the vial surface, the glass itself, changes the pH of the solution in the vial. Now you can say, especially the HPLC guys here in the audience, hey, no problem, we have a buffer, and we buffer all the time that the pH change is not happening. Well, yes, but are you really sure that the pH shift never influences your molecules? And where do you buffer? Do you buffer the small sample in the vial, or are you doing your HPLC run with a buffered solution? Another point is, do you exactly know the pKa or pKs value of your target compound or of all the compounds in your sample mixture? If yes, okay. And you know, for a reproducible reversed phase chromatography, you want, in the best and optimal case, everything to be protonated, that you do not have a retention time shift. But if the vial and your sample in the vial in water changes the pH, it might be that some of the pKa, pKs values are changed and the vial falls out of that optimal range where you want it to be. Another point is buffers in your solvent and in your run. When you do high sensitivity MS detection, you want the buffer concentration to be as low as possible in order to avoid ion suppression. And in the ideal world, no buffer at all. So when you reduce the amount of buffer, it may again be a risk that your molecule moves out of the target pKa, pKs value range. How does this look? Here you can see some of the bars. Vials may shift the pH in the vial up to 1.6 pH. This is a lot, and it's not negligible any longer. And you should have this on the radar when you work with molecules which have a lot of functional groups, and the pKa and pKs value needs to be in a defined range. And you see here that the gold grade vials have the lowest pH shift of all the vials we investigated here. What is this effect, you may ask now? Well, glass. What is glass? What is the glass surface and what happens? Let's talk a little bit about chemistry and physics. All autosampler vials you can buy today on the globe are from first hydrolytic class glass. And this is a standard which is based on the pharmacopoeia, all pharmacopoeias, not only German, European, but as well US and Japanese. Glass is made out of sand, so silicium dioxide, and the surface of the vial has OH groups. So in a simplified world, this is an alcohol. Yeah, and this proton can react with your molecule on a micromolecular environment or surface around the glass surface. So basic compounds can grab the proton, or if it's deprotonated here, your carbocyclic acids can be deprotonated because the hydrogen, the oxygen molecule here is grabbing the proton from your carbocyclic acid. So you have heavy interactions here. You cannot see with bare eyes. The only thing what you can see is adsorption effects or missing substance. Yeah, not 100% in and 100% out. Luckily, we have some variations and options here. The first hydrolytic class glass is divided into 3 groups. You can have a 33, a 51, and a 70 type expansion glass. What does that mean? It's the thermal expansion coefficient, which is for us in chromatography not worth to mention. It tells us nothing. It just says a vial at 0 degrees has that dimension, and a vial at 200 or 300 degrees has that dimension. But for chromatography, where is the relation between that number and the effect? I explain it all the time this way. The lower the expansion number, the less active OH groups you have on the glass surface, and the less interactions and adsorption effects you may have. And this tendency to adsorb compounds increases by increasing the number. So the difference is based in the composition and the content of side ingredients in the glass as well. And these reasons here that you have more or less OH groups is the difference, or this differs the adsorption effect or ability in the different vials. So the rule, the lower the expansion rate, the less active SiOH groups you have, and the less polar adsorption you will see and can expect. And parallel to that, this is logically, but I want to mention it, the lower the sample concentration or the volume is, the higher is the risk of adsorption. Because when you have tons of substance in the vial, nobody cares. But if your concentration goes down to nano or femtograms, this is a different story. Because when you have only a few molecules, and these few molecules adsorb to the glass wall, you lost them. What you are not injecting into your GC or HPLC column, it's lost. You can have a multi-million high-end equipment. If the compound does not leave the vial, you have nothing to analyze. And this is why we recommend very often our Showstart Gold grade vials, because they are have the lowest type of glass and the lowest adsorption tendency. And we have another option. You can reverse the polarity because glass is polar and use plastic. Okay, then you have no polar interactions any longer, but there are some other disadvantages with plastic. I come to that a little bit later, but have in mind glass, plastic, and the third one I told you, it's silanized product. Yes, a silanized vial is another option as well, with some of the disadvantages of non-wanted ghost peaks coming out of the silanization. Surface is perfect, but you may have some confusing results out of your MS. Glass is not only silicium dioxide. There are some other compounds in, because when you make glass out of sand from the beach, you have some other compounds in: aluminum oxide, calcium, potassium, magnesium, sodium, barium, and some other stuff. But the major part in a good autosampler vial should be silicium dioxide and boron oxide. This is why we often call these vials boron oxide vials. And you see that depending on the grade of the expansion, you see that the quantity of side compounds increases as well. Why is this an issue? These are metals. And if you have compounds which are able to do a halide complex, you may see loss of compounds because of this metal central ions. And especially, this is something here, amber vials. I know there is a rule out there. When you have light sensitive compounds, use amber glass. Okay, in general, yes. But many times when I ask you or your colleagues, how many light sensitive compounds do you really have? And they say, well, it's standard. We always use amber vials. And I say, well, and all your compounds are light sensitive, right? No, it's just a few of them. Okay, my recommendation is, because the iron central ion is an excellent halide building central ion, and if it's not 100% urgently required, do use clear vials instead of amber. And only for the ones where you really know it's necessary, use amber vials, because the clear vials are superior in terms of adsorption risk. A little bit to the glass surface and how it looks. Here is a microelectron picture set, and you can see that the 33, 51, and 70 type, none of these are really plain. You may think, oh, glass, it looks perfect. It's a super super smooth and plain surface. No, it's not. Yeah, so you see here the pickles and spikes, and you see that the surface becomes more rough when you go to the higher expansion grade vials. And it's very extreme for the 70 type glass. And this sponge here is to remind you, the higher the surface is, the higher the adsorption tendency is as well, because just simply of the surface. And it's more like a sponge here, and this is a lot smoother and more plain on the 33 type. Yeah, plastic. This is something you may be waiting for and say, well, we bypass all these problems with glass because we always use plastic. Okay, is plastic always okay? Are there only advantages with plastic? No, because the plastic surface, here is the same picture compared to the glass surface, has exactly the opposite problem. You have a super non-polar surface, and this is not interacting with your amines or carbocyclic acids or oxygen groups, but it can interact with the rest, so with the non-polar part of your molecule. And then you have the same problem. If you're dealing with some non-polar compounds, let's say a fatty acid has just one acid group and a lot of carbon atoms. And if you put that into a plastic vial, you may have a problem at the end. So you always have to have in mind that no surface has zero effect on your molecules. It depends on your analyte and your molecule. Yeah. Nevertheless, we have plastic vials as well, because for some products, it may be beneficial to use plastic. Plastic is not as inert as glass, so you're limited here in the plastic world by using very strong non-polar solvents. This is the disadvantage of plastic, and this is why plastic is not used all over the place in chromatography today. Microsampling. Well, if you have tons of compound and always 1.5 or 1 milliliter, all good. But sometimes a lot of people come to me and say, well, I just have 75 microliters. What can I do? What is the best recommendation here? Okay, you need a reduced volume sample handling container. And you have different options to do that. Method one is you use a glass insert in a standard glass vial in order to reduce the volume, because your sample is only in the microinsert. And our recommendation here is always use the microinsert with a spring at the bottom, because the spring has two big advantages. One is it lifts the microinsert over the top of the vial, so the filling is very easy and reproducible. And when the cap presses the insert down, the feather or the spring here centralizes the insert to sit pretty straight, that the needle is not touching the conical part of the insert. Method two, a fixed insert. So this insert is connected either with the bottom or the top of the vial, always centered, very convenient, and works perfectly as well. But it's not as flexible as this one, because here you can use the vial alone or the vial with insert. Here, this one always has the limited volume of the microinsert. And method three is a kind of combination of both. You have vials with a specific bottom shape or a specific inner shape. And here you see you have a V bottom, or this champagne vial makes the volume, especially at the bottom part, pretty limited. These vials can handle 75 microliters, no problem. You get reproducible results. You can put in 1 mil, no problem as well. And these are very flexible when you have from sample to sample changing volumes. Hint, the autosampler needle needs to be adjusted, or you have the luxury of a bottom sensor instrument. Here are some pictures. How does it look? the recommendation, or not the recommendation, the rule is for a normal 1.5 or 2 ml vial, 170 microliter is the limit. I do not recommend to use less than 170 microliter in a normal vial. If you have more than that, all good. If you have 100 microliters, like in this example, you see that it makes a lot of benefit and helps to use micro inserts with or without spring, fused insert vials, or these bottom shaped vials. And we can drive that to the limit and say, okay, what is if you only have 5 microliters? Well, this is a very, very critical volume, I would say, because normal vial, no way. And even this vial here, critical, the total recovery vial works a lot better, and a small insert works as well. So 5 microliter is a very critical volume. And when you say, but this is what we are dealing with, it limits the number of options you have on vials to use, but we still can offer 1 or 2 options for a 5 microliter volume challenge. So you see, we have a lot of vials and a lot of different bottom forms and shapes in clear and in amber. So I'm pretty sure you will find the right product in our portfolio. Another problem when it comes to bottom forming and funnels, you may have seen that before. The surface tension, especially of pure water, is pretty high. And when you're not very sensitive in filling the vial, it may happen that from 100 vials in 5 or 6 or 7 of them, you have a bubble at the bottom. And you can imagine that this is not healthy for your reproducibility, because when the needle goes down to the bottom, you may not extract liquid and sample. You may extract at first the bubble. And so you want to inject, let's say, 5 microliters. Well, 2 of these 5 microliters are the bubble before the solvent is assessed. So the bottom form of the conical inserts or the conical bottoms is a key for reproducibility, because with this one, it's a lot easier to fill it without the risk of bubble creation here. These are our total recovery vials. Different theme, different topic, different mindset. Certification. You may use products which are not certified at all, or you may use products which are certified, and there are products out there with different grades of certification. What does it mean, and what is behind this different grade of certification, and where are the benefits for you, and which one are you using, or should you use for something you want to do? Let's start with the normal product. Friends of ours here have a button on their product which says autosampler approved, certified, but it's physical dimension certified, which means the height and the OD and the ID is checked and will work. Okay, this is a physical spec or physical dimension certification, has nothing to do with the chemical certification, which we have in level 2, because this is a real LC/GC certification, which means we take the product, give it to the lab, they do an extractable profile via GC and LC, so GC FID and LC UV, and you get the product with the certificate that you can see directly what are the extractables, what do I have to expect. You can top this with an LC and GC MS certified product. Here you do the same, you take the product, give it to the lab, but and now you're doing GCMS and LCMS. So the sensitivity and the grade of information is higher because you can see a lot more what is in or not in that combination of vial and closure. There is another certification, inclusive low adsorption test. This is done by our friends from Waters, only for LC vials and only for TrueView vials. And there is another certification, which is the top of that, is the MS certified certification we do. Here we do not only take the vial and the closure and give it to the lab. The products are cleaned previously to the MS, GC and LC-MS certification. What does that mean, cleaning? Well, everybody knows a car wash. And you can imagine when you do that with autosampler vials, the vials coming out of that car wash or out of that cleaning process with 4 times distilled water in a super low particle clean room. This vial is not only LC and GCMS certified, it's cleaned and certified. So the grade of particles in the vial is reduced significantly. Well, where is the benefit of that? Normally, nobody thinks about how many particles do we have around us. So where we now sit and stare at the monitor, how many particles do we have in the room where we are living? And how many particles are in a vial? And you would be surprised how high this number could be. And with this certified cleanup process, the MSCert Plus process from Thermo Fisher Scientific, you reduce these particles close to zero, which has the effect that your complete workflow, your columns, your Fritz, your MS, every particle is more or less vertically removed, and do not increase ion suppression and do not contaminate your samples. Or people who do direct MS injections, you simply do not have to clean up your MS source so often because the product is so clean and so pure that the maintenance frequencies can be enlarged in month or half a year or maybe in a year. So very specific product for people who need a very, very clean environment for their samples. Septa. Again, we change the topic here. I'm 100% sure that nearly everybody of you here in the audience used or is using a white red septum. So white silicone red PDFE. Sometimes you use red and transparent PDFE, so red septum and transparent PDFE. But this is something you know and you have seen. But color does not mean nothing. And there are definitely differences in septa qualities depending on the silicone, depending on the kind of PDFE used, and depending on the grade of purity of these products. And what we did in Thermo Fisher Scientific here for our Thermo Scientific products, we divided our portfolio into 3 performance levels, performance level 1, 2, and 3. And performance level 1 is an everyday product, pretty simple. And the performance level 3 products are super clean, super pure, and the risk of extractables out of these products is close to zero, even under super high sensitive trace analysis. So there is a chance, depending on what you need, to choose from different quality grades of septa in order to meet all your requirements. Is it a super simple system with very cost-effective products? Yes, we do. We have that. Or is it a product where you say, well, you know, I need the best of the best. I'm working on the edge of what is possible on the science today. You need definitely a performance level 3 product. And what is a good and a bad septum? This is just a simple GC comparison. What you normally expect is that over 95% of your chromatogram, you get nothing, really nothing out of the septum, independent from the solvent you use. But sometimes you get even at mid or lower or mid temperatures, ghost peaks, spikes, non-wanted analytes and peaks. This is a bad septum. And sometimes it's digital, easy as that. If you have, does not matter if it's GC or HPLC, non-wanted peaks in your chromatogram, you can, in the first stage, check the column, change the column, check your injection system, check your detector, check your pump. But it's a lot easier and cheaper and quicker just to check your vial and your septum. Is the issue coming from there? And it's pretty clear, but nobody realizes that it's a lot easier to spend 1 cent more for a vial and a cap than to buy a new detector for $250,000. The silicone is not alone the point where you should put your interest on, because when you buy something, you trust that the PDFE layer is integer and absolutely perfectly in shape and has no defects and no holes or any kind of bad parts. But well, when you look at the electron microscope pictures here, even if you see the scratches, this is a good PDFE layer. This one is a bad PDFE layer, because nobody knows, are the valleys you see in here, are they just on the surface, or are they going down to the silicone or the natural or butyl rubber part? So you have to trust the supplier of your products, that they know what they are doing, and that not only the silicone or the butyl is a very low bleed product, that the PDFE layers as well are absolutely fine and perfect for what you want to do, that you're not losing sample, or that your solvent is not attacking the rubber part, which then contaminates or recontaminates your sample. Septa hardness. You may ask, hey, I heard about that septa are available in different hardness, shore hardnesses. What is that? What is behind, and why, and what is the benefit or the risk? Well, the risk is that your needle is bended, breaking, or damaged. And if the needle is not working properly, maybe your autosampler stops overnight and your samples are not processed. And different hardness, septa with different hardness have different trampoline effects. I call it this way because a needle needs to go through and penetrate the septum. If it's a blunt needle, it's pretty hard to do. If it's a very sharp needle, it's okay. But the harder the septum is, the lower the trampoline effect is, and the sharp needle goes through a lot easier. But if you have a blunt needle, the softer the septum is, you use the trampoline, and at a certain point, the needle penetrates it. If you have the wrong combination, the needle may be damaged. For the fraction here, which are using bonded caps, so septa bonded to the cap, and somebody told you this is the best product in the world, and you will never get any trouble when you use our bonded caps. Does not matter if it's pre-slit or non-pre-slit. I have some news for you. Bonded caps or caps with bonded septa are not the best solution all the time. Because when you do high sensitivity HPLC analysis and you use bonded caps, it could be that the bonding process, which is a pretty, it's not a sensitive process. It's hard and with high temperatures, and introduces side compounds which could be extracted by your needle. And here you see some examples of bonded caps where you see either non-identifiable mountains in your chromatogram or non-wanted not from your sample coming peaks. And this is definitely not the case when you use non-bonded septa, because the bonding process introduces extractables and leachables. And if you think that your bonded cap is the best product in the world, trust me, in the meantime, companies move away from bonded caps because they exactly found that fact that the bonding introduces extractables and leachables to their sample. So my recommendation is, if you do not need it, if you do not want that, have a look at our SureStop AVCS closures, which provide you a reliable system without bonding. And what are these compounds coming out of that bonding? Here you see some compounds. These are siloxanes, which are formed during the plasma bonding process. Crimpers and crimping, well, crimp vials and crimp caps are the oldest autosampler combination. Well, everybody knows crimpers, manual crimpers, electronic crimpers are out there. By the way, we manufacture our manual crimpers ourselves in Germany. So these products are all made in Germany. The electronic crimpers help you to make the crimping process more simple, less stress for your hands and your fingers, and a lot of helpful tools in these electronic crimpers. And when it's adjusted once properly, it works perfectly. Well, this is a nice feature. 8 languages are accessible in this electronic crimper menu here. Why is crimping here a theme, and how can we improve our analysis? Well, crimping is not always perfect, because many people think, oh, I adjust the crimper, well, that is really hard and tough, and there is nothing more to do. Well, when you over crimp, you see this effect here, that the septum comes to the top, or the septum is sinking significantly into the vial. And you say, yeah, so what? It's really tight. Yes, but after tight, it becomes loose. But this is a different thing. What I want to say here, you are over tightening here a rubber. And what happens when you're over tightening a rubber, when it goes deep into the vial or onto the top? The product, the polymeric fibers are stretched significantly. And when you have stretched fibers, the hardness of the septum, we talked about that before, changes. The septum becomes harder. And when the septum becomes harder, it's harder for the needle to penetrate. So an over-crimped product can be a reason that your autosampler stops. It's as easy as that. So we gave some hints and a pretty nice, helpful slide here, how to crimp properly. But it's not only limited to crimp. You can overscrew your vial as well. You never heard about that, but maybe you have seen this. So you can imagine, if you have a small lady in the lab and a big bear, do you really think, when both do the same on this 9mm screw thread vial, that one may look like this and the other one may look like that? But over tightening, again, is the same problem. The septum becomes harder, and you increase the risk that your autosampler stops. And we are convinced that nearly 90% of everybody over screws and over tightens the screw thread vials and the septa. Is there a solution? Yes, it is. We have a patented system in our SureStop portfolio. This is the SureStop vial with the AVCS closure. I mentioned that before. What is the secret? It's super easy. The SureStop vial has a glass rim below the thread, which stops the cap at a defined point, and the compression of the septum is always ideal, independent from the operator. So no over tightening, always a tight seal, no push through, as you see it here on the bottom. And another big benefit is the cap always sits square. You do not have tilted caps like you see it over here. Well, let's look a little bit back to the past. 40, 30 years ago, chromatography was a very manual process. Then the Industrial Revolution hit chromatography and autosamplers were developed, so robots which do the work. And today you can do thousands of samples overnight if you want without manual interaction here. Why is this a theme for this presentation here? Because how can you make your life easier or more rapid or time and space saving? Here you see 96 vials in a rack, and here you see a 96 well plate. So the difference in space consumption, I think it's pretty obvious. Another advantage, because well plates are normed, you can use pipettes, multi-pipettes, and fill not only vial by vial by vial by vial, you can fill 6 or 8 or 10 or 12 parallel. This saves a lot of time. And nearly today, every autosampler out there can use, instead of vials in racks, well plates. And here we have something coming back to the beginning. Well plates are from plastic, right? We only offer polypropylene well plates, so we do not have polystyrene, we do not have polyacrylic ones, because we want to be the plates compatible with HPLC, so methanol acetonitrile. No problem on these plates. Here we have as well different types of plates, standard, low cost, certified ones, and high-tech ones. And what we did is we checked the plates on extractables that you can be sure that when you put your valued sample into a plastic plate, that you do not have negative effects by leaching or by cross or recontamination. And in order to seal the plates, we offer mats and different types of mats, silicone mats or silicone with PDFE cover, in order to give you the same security as you have with a glass vial and a screw thread or crimp closure. There are only some limits to use well plates. You cannot use well plates when you need a single sample identification, or when you have solvents which are not compatible with polypropylene, or when you have to transport separate samples out of these 96 or 100. You cannot do derivatizations, so there are some limits for the well plates, but a lot of benefits as well. This one here is nearly the same what we had with the plastic vials. You have the same non-polar interactions. One thing I want to show you, when you think a well plate is pretty good, why are there different well plates on the market? You can see you have flat bottom, round bottom, and V bottom well plates. But what is important as well, when we come to micro volumes or very low volumes, you have to take under consideration that the surface tension of the solvent, especially the water, leads to this type of picture. So for a flat bottom well plate, in the middle, there is not enough liquid left to be assessed by the needle. So if you have very low volumes, a V bottom plate is always superior. Just as a reminder that the surface tension for very low volumes may lead to non-wanted zero injection effects. The seals, I said we have specifically seals for 96 and 384 well plates. The transparent ones are silicone, and the blue ones, does not matter if light blue or dark blue, are PDFE covered ones. We have them slit and non-slit, so they can be used with steel needles or with plastic needles or pipette tips. It will work all the time. So if you have an idea of switching from vials to well plates in order to double the capacity of your existing autosampler, we have some solutions, and we should talk about that. This is something special. looks like a normal plastic plate, but if your solvents become a little bit more aggressive or a little bit more non-polar, you may be worried to put your sample into a plastic plate. But this plate plus is a plastic plate with a glass coating. So the complete plate, not only the cavity, the complete plate is coated with a 200 angstrom of glass. This gives you the security that at least for a medium and acceptable time frame, even more aggressive solvents do not attack the plastic or lead to high extractables out of the plastic. If you need a high-end solution in the well plate format, this may be something you should take a look at. These plates are called Plate Plus. Okay, we come to the end. Where can you find help? Where can you find these products? Well, homepage, definitely. You can find the thermal scientific products on vwr.com. There is a catalog. It's just one catalog, but it's a big one where you can find all the vials, all the caps, all the closures in the different performance levels and the well plates for sure. All the types of plates and mats in 96 and 384. And everything available via Avantor for sure. So let me sum up. It was a lot, I know. We want to avoid that you lose sample. We want to avoid that your sample is contaminated, recontaminated, or gets extractables or leachables out of any product you use for sample handling. And we want to improve your reproducibility in your workflow, that your high-end equipment can be used really to the end, and that even if you will not get 100% out of the 100% you put in, we want to enable you to get 98% out, if possible. Don't forget, valves and closures are at the beginning. And when you have troubleshooting, please do not forget to start at the beginning and don't blame all the time your high-end equipment or the column or everything what's behind. Yeah, I think I'm more or less done and can stop here with this slide and say, if you have questions, I don't know if they are in the chat now or if you want to ask questions now. And I want to thank you. And yeah, thank you.
Thank you very much. Thank you very much. Thank you very much, Detlef.
Yeah,
it was really. Thank you very much, Detlef. It was really complete and great. I've learned many things, and I would like also to tell a big thank you to Jennifer Suzinski and Florence Valentin. Yeah, you have just received a question, Detlef. Do you know how to prevent the needle from picking up a piece of the septum during penetration and sucking it into the HPLC system?
Can you repeat the first part of the question, Didier?
Yeah, I can repeat. Do you know how to prevent the needle from picking up a piece of the septum during penetration and sucking it into the HPLC system?
Yeah, there are about 5 or 6 needle types out there in the market. And my recommendation always is when you have the risk or you face the problem of picking pieces or stamping pieces out of the septum, my first recommendation is use a side taper needle, not a normal sharp or a blunt needle. Use a side taper one, because these needle types are made not to cut out anything out of the septum. This is my first recommendation here. Or use a pretty hard septum and a normal sharp needle, but take care that the needle is sharp. And when the needle is not sharp any longer, replace it. I know it's a cost factor, but this is my recommendation.
Okay, thank you very much, Ditlev. So I think that yeah, we're almost in time. So I would like to add something for concerning the brochures. So you can immediately download 3 brochures, so 2 flyers and the big catalog. But don't be worried if you have not enough time. You can find everything in the website. So yeah, in this landing page, you will be able to find the catalog, the flyers, many things. Tomorrow you will receive the recording, so feel free to share with your team. So I think it could be interesting for you to share this information. In some minutes you will receive a survey. Feel free to give us your feedback, because it's still important for us to know your opinion, and we can improve the future webinars. And the last point is that in 1 week you will receive a follow-up mail with additional information, linked to the website, brochures, etc. So I think that it could be really helpful again for you. So thank you again for your participation. Thank you, Ditlev, for this great webinar. And now I think that we can close the webinar. And I would like to wish you a great evening. Thank you very much. Bye-bye.
Thank you all. Bye.
Bye-bye.